Hi there! This video is all about MIS. As my final requirement to this subject, we were tasked to discuss the 3 among the 7 given topics. So I've decided to choose TPS, the Transaction Processing System, DSS, Decision Support System, and IES, Information Executive System. So let's start. Let's define MIS. A Management Information System is an information system used for decision making and for the coordination, control, analysis, and visualization of information in an organization. The study of the management information systems involves people, processes, and technology in an organizational context. The Transaction Processing System. Definition. Transaction processing is information processing in computer science that is divided into individual, indivisible operations called transactions. Each transaction must succeed or fail. As a complete unit, it can never be only partially complete. Another definition, transaction processing is a way of computing that divides work into individual, divisible operations called transactions. A transaction processing system is a software system or software-hardware combination that supports transaction processing. History. The first transaction processing system was Sabre, S-A-B-R-E, made by IBM for American Airlines, which became operational in 1970, designed to process up to 83,000 transactions a day. The system ran to IBM 7090 computers. So a little trivia about Sabre. Sabre is a global distribution system owned by Sabre Corporation. It's used by travel agents and companies around the world to search, price, book, and ticket travel services. Provided by airlines, hotel, car rental companies, rail providers, and tour operators. Sabre aggregates airlines, hotels, online and offline travel agents, and travel buyers. So the next history is the Hewlett-Packard NAND system was a hardware and software system designed for online transaction processing, or OLTP, introduced in 1976. The system were designed for transaction processing and provided an extreme level of availability and data integrity. In addition to airlines, transaction processing is used by large banks, credit card companies, and hotel chains. Processing types. Transaction processing is distinct from and can be contrasted with other computer processing models, such as batch processing, time sharing, and real-time processing. So, batch processing is execution of a series of programs, jobs, on a computer without manual intervention. Several transactions called a batch are collected and processed at the same time. The results of each transaction are not immediately available when the transaction is being entered. There is a time delay. Another one is the transaction processing system, which belongs to the processing types. It's a type of information that collects, stores, modifies, and retrieves the data transaction of an enterprise. Transaction processing system also attempt to provide predictable response times to requests, although this is not as critical as for real time systems, rather than allowing the user to run arbitrary programs as time sharing. Transaction processing allows to only predefine structured transactions. Each transaction is usually short duration, and the processing activity for each transaction is programmed in advance. So the transaction processing system features. First is the performance. Fast performance with a rapid response time is critical. Transaction processing systems are usually measured by the number of transactions they can process in a given period of time. Continuous availability. The system must be available during the time period when the users are entering transactions. Many organizations rely heavily on their TPS. A breakdown will disrupt operations or even stop the business. Data integrity. The system must be able to handle hardware or software problems without corrupting data. Multiple users must be protected from attempting to exchange the same piece of data at the same time. For example, two operators cannot sell the same seat on an airplane. The ease of use. Often users of transaction processing systems are casual users. The system should be simple for them to understand, protect them from data entry errors as much as possible, and allow them to easily correct their errors. Modular growth. The system should be capable of growth at incremental cost, rather than requiring a complete replacement. It should be possible to add, replace, and update hardware and software components without shutting down the system. So we have to proceed to the types of TPS. Processing in a batch. Transaction may be collected and processed as in batch processing. Transactions will be collected and later updated as a batch when it's convenient or economical to process them. Historically, this was the most common method of information technology. Did not exist to allow real-time processing. Processing in real time. This is the immediate processing of data. It provides instant confirmation of a transaction. It may involve a large number of users who are simultaneously performing transactions which change data. Because of advances in technology, such as the increase in the speed of data transmission and larger bandwidth, real-time updating is possible. Database for TPS. A database is an organized collection of data. Databases offer fast retrieval times for non-structured requests as in a typical transaction processing application. Database for transaction processing may be constructed using hierarchical network relational structures. So the first is the hierarchical structure. Organizes data in a series of levels. Its top to bottom like structure consists of nodes and branches. Each child node has branches and is only linked to one higher level parent node. Network structure. Network structures also organizes data using nodes and branches, but unlike hierarchical, each node can be linked to multiple higher parent nodes. The last one is the relational structure. A relational database organizes its data in a series of related tables. This gives flexibility as relationships between the tables are built. So we have to proceed to features of database for TPS. It must good data placement, short transactions, real-time backup, high normalization, archiving of historical data, and good hardware configuration. Backup procedures. Since business organizations have become very dependent on transaction processing, a breakdown may disrupt the business. Regular routine and stop its operation for a certain amount of time. In order to prevent data loss and minimize the disruptions, there have to be well-designed backup and recovery procedures. The recovery process can rebuild the system when it goes down. Types of backup procedures. There are two main types of backup procedures: the grandfather, father, son, and partial backups. Advantages of the TPS: batch or real-time processing available, reduction in processing time, lead time or order cycle time, reduction in inventory, personnel and ordering cost, increase in productivity and customer satisfaction. So let's proceed to another topic, the DSS, Decision Support System. Definition. A decision support system, DSS, is a computerized program used to support determinations, judgments, and courses of action in an organization or a business. Another definition is the DSS sifts or put through and analyzes massive amounts of data, compiling comprehensive information that can be used to solve problems in the decision making. Typical information used by a DSS includes target or projected revenue, sales figures or past ones from different time periods, and other inventory or operations related data. Understanding a DSS. A decision support system gathers and analyzes data. Synthesizing it produces comprehensive information reports. In this way, as an informational application, a DSS differs from an ordinary operations application whose function is just to collect data. The DSS can either be completely computerized or powered by humans. In some cases, it can combine both, computerized and used by the user. The ideal systems analyze information, they actually make decisions for the user. At the very least, they allow human users to make more informed decisions at a quicker pace. Key takeaways. A decision support system is a computerized system that gathers and analyzes data, synthesizing it to produce comprehensive information reports. A decision support system differs from the ordinary operations application, whose function is just to collect data. Decision support systems allow for more informed decision making, timely problem solving, and improve efficiency in dealing with issues or operations, planning, and even management. Using DSS. The DSS can be employed by operations management and other planning departments in an organization to compile information and data and to synthesize it into actionable intelligence. In fact, these systems are primarily used by mid to upper level management. For example, a DSS may be used to project company's revenue over the upcoming 6 months based on a new assumptions about product sales. Due to a large number of factors that surround projected revenue figures, this is not a straightforward calculation that can be manually. However, a DSS can integrate all the multiple variables and generate an outcome and alternate outcomes, all based on the company's past product sales data and current variables. Important to note, a DSS can be tailored for any industry, profession, or domain including the medical field, government agencies, agricultural concerns, and corporate operations. The components of the DSS. 3 fundamental components are the database or knowledge base, the model, in example, decision context or user criteria. The next is the user interface, and the users themselves are also important components of the architecture. Development frameworks. Similarly to other systems, DSS system supports required structured approach, such as framework includes people, technology, and development approach. The early framework of decision support system consists of 4 phases: intelligence, design, choice, and implementation. The DSS component or classification. DSS components may be classified as inputs, factors, numbers, characteristics to analyze, user, knowledge and expertise, inputs requiring manual analysis by the user, outputs, transform data, which is DSS decisions are generated, decisions, results generated by DSS-based user criteria. Types of DSS: status inquiry system, data analysis system, information analysis system, there's the accounting system, and model-based system. Characteristics of the DSS. The primary purpose of using a DSS is to present information to the customer in an easy-to-understand way. A DSS system is beneficial because it can be programmed to generate many types of reports, all based on user specifications. For example, the DSS can generate information and output its information graphically, as in the bar chart that represents projected revenue or asset briefing report. As technology continues to advance, data analysis is no longer limited to large, bulky mainframe computers. Since a DSS is essentially an application, it can be loaded on most computer systems, whether on desktops or laptops. Certain DSS applications are also available through mobile devices. The flexibility of DSS is extremely beneficial of all users who travel frequently. This gives them the opportunity to be well informed to all times, providing the ability to make the best decision for their company and customers on the go or even on the spot. Benefits of the DSS: improves efficiency and speed of decision-making activities, increases the control, competitiveness, and capability of futuristic decision-making of the organization. The last is the facilitates interpersonal communication. It also encourages learning and or training. Since it's mostly used by non-program decision, it reveals new approaches or set up new evidences for an unusual decision, helps automate managerial processes. So we're now down to the last topic, which is the EIS, Executive Information System. Definition: an executive information system, also known as an executive support system, is a type of management support system that facilitates and supports senior executive information and decision-making needs. So it is related or relative of the decision support system. EIS emphasizes graphical displays and easy-to-use user interfaces. They offer stronger reporting and drill-down capabilities. The term EIS lost popularity in favor of business intelligence, with the sub-areas of reporting, analytics, and digital dashboards. The history. Traditionally, executive information systems were mainframe computer-based programs. The purpose was to package a company's data and to provide sales performance or market research statistics for decision makers, such as marketing directors, chief executive officer, who were not necessarily well acquainted with computers. The objective was to develop computer applications that highlighted information to satisfy senior executives' needs. Typically, an EIS provides only data that supported executive-level decisions, not all company data. As sometimes service companies adopt the latest enterprise information systems, employees can use their personal computers to get access to the company data and identity information relevant to their decision making. The components of the EIS: hardware, software, user interface, and telecommunication. So first is the hardware. The basic hardware needed to the physical typical EIS includes 4 components: input data into devices, the central processing unit, the storage files, and output devices. Second is the software. A typical IS includes software components: text, database, graphic base, and model base. The user interface must be efficient to retrieve relevant data for decision makers, so the user interface is very important. Several types of interfaces can be available to the EIS structure, such as it can schedule reports, question answers, menu-driven, command language, natural language, and input and output. Telecommunication. As decentralizing is becoming a trend among companies, telecommunications plays a pivotal role in network information systems. Transmitting data from one place to another has become crucial for establishing a reliable network. In addition, telecommunications within an EIS can accelerate the need of access to distributed data. It can be both by scientific and business means. The advantages of this system: it's easy for upper level executives to use. Extensive computer experience is not acquired in operations. Provides strong drill down capabilities to better analyze the given information. Information that is provided is better understood. EIS provides timely delivery of information management, can make decisions promptly, improves tracking information, and offers efficiency to make decision makers. So the disadvantages of this system: system dependent, limited functionality by design, information overload for some managers, benefits hard to quantify, high implementation costs. System may become slow, large, and hard to manage. Need good internal processes for data management, may lead to less reliable and less secure data. Excessive cost for a small company. So that's all. Thank you.